Huh?
My aunt is a Karen and she has a reputation with Amazon. Right? They accidentally sent her the wrong thing and she returned it. She didn't even complain. They sent her 3 of the things she ordered, so now they had 3 air fryers. It's like, why do you need to?
All right, so some people says, can I go over the second derivative? Okay, so first thing, if you got your derivative wrong on Tuesday's test, then that means a lot of things gonna go wrong. So when it comes down to something that's more sequential, like it follow one lead to one another, you gotta make sure those questions is 100% precise. So it have a 2x squared minus 9 all over x squared minus 4. First of all, I'm gonna tell you how to do symmetry. You're gonna plug in negative x, and that's gonna be 2 to the negative x squared minus 9 over negative x squared minus 4. Now you see, I cannot talk over you guys. So 2x squared minus 9 over x squared minus 4. It go back to original. If it go back to original, sorry. If it goes back to original, then that is symmetry to the y-axis. And it's also known as an even function. If you go back exactly opposite. So what do you mean by exactly opposite? If you go back to become like this, that is called an odd function. That's symmetry to origin. Today you have homework question. Have different type of symmetry. Okay, so guys, you need to know how to take a derivative. If I take a derivative on the first one, so it's gonna be low d high, which is 4x, I think, minus high d low over low. And I will just distribute the top, so it'll be 4x to the cube minus 16x. This is gonna be negative 4x cubed, and negative 4x times negative 9, so it's be plus what? This is 9. So negative 4 plus 36 x over x squared minus 4 to the square. So this one should cancel out, and this should be 20x over x squared minus 4 to the square. Now, that is the second derivative. If I do second derivative, it's going to be low d high minus high d low over low. And then that's going to give you, I'm going to factor out x squared minus 4, just because I think that will be easier. And so that is going to be 20. Did I do something wrong?
You didn't square the first thing in the
This one, 4?
well, like on top, first low.
Oh, low. Okay. Low d high. I mean, double check. I forgot a 2 and 4 on the bottom. So low d high minus high d low over low. Okay. So now I factor out x squared minus 4. So there should be 20 times x squared minus 4 inside, because I take out x squared minus 4. And if I take out x squared minus 4, I should have minus what'd you say? You cannot cross them. 20x squared minus 4 times 20x times 2, which is 40x, which is 80x. X squared, right? Yeah. X squared minus 4 to the 4th. Now I can cross it out. So that's equal to 20x squared minus 80x 80 minus 80x squared all over x squared minus 4 to the third. So that'll be negative 60x squared minus 80 all over x squared minus 4 to the third. So I will do a number line test here. I'll factor out a negative 20, so it'll be 3x squared plus 4 over x squared minus 4 to the third. So in this here, I will do negative 2 and 2. Why do I do negative 2 and 2? Because this one doesn't matter. Do you know why 3x squared plus 4 doesn't matter? Yes.
Because no matter what, it's never going to get a negative.
Yeah, so it doesn't have sign contribution. But you can put it in if you want to. I mean, it doesn't help you, doesn't hurt you. And this one's going to be positive, doesn't matter what all the way through. But minus 20 matter because it's going to hurt everything negative. Now, x squared minus 4, this one's going to be, I believe, positive, negative, positive. So it'll be negative, positive, negative. So therefore, it's going to concave down, concave up, concave down. But it's a true inflection point. Yes.
When do you put the denominator?
Okay, so here's a question. When do you put denominator into a number line? You always. And that's the x squared plus 4, because that's imaginary. But you don't need to put imaginary in there. But the bottom part is categorized as not an inflection point, but you can have a concavity change without inflection point, because the original function cannot equal to 2 as well. If you look at original function, domain says cannot equal to 2, and also it says vertical asymptote at 2. So tricky question, is it 2 inflection point? No, because it's asymptote. But it did have a concavity change. You would think that this is an inflection point. This is not, because there was no point there. Do you guys know how to find slant asymptote? Long division. Whatever in the front, the last case was x. X was a slant asymptote. Right? So you can find those things. Yes. What'd you say?